scientific cruise where he wanted to basically observe artists and scientists working together to explore what kind of knowledge and experience can that intersection create.
Okay.
Historically, artists have been on these types of cruises quite a long time with abilities to draw plants or draw animals. But this is in some ways a new way to work together because we're exploring as they're exploring as well. So we're not translating what they find into an aesthetic or visual representation, but are trying to conduct our own aesthetic research with them.
My name is Donald McDonough. I'm Director of Policy, Innovation and Research.
There's a bunch of good stuff
Ireland.
here.
I'm delighted to have the privilege to moderate this
I still remember when we met very clearly because it was these two artists invited to join a scientific expedition. I have been at sea many times and I know what does it mean to be on a boat. And this boat particularly, because this is a big boat. There are a lot of decks, there are a lot of corridors, a lot of cabins, and a lot of instruments, and yeah, you get lost very easily. They were curious about what we were doing, so what the scientists were doing, and I was very curious to know what they were doing. And we met there. I think it was our curiosity and also the will to really discover something else. For example, I was showing them the plankton net. You can take samples of organisms from the water, and then I showed them the instrument that I generally use, which is a gravity quarter, which is a long cylinder of steel, and we use it to bring up the sediment from the seafloor. I'm interested in going back in time and see what has happened 10,000 years ago, 20,000 years ago, and so on. And they were interested to know how these sediments can tell me the history of our ocean.
The voice of the marine science community together.
We were lucky enough to get 217 centimeters worth of sediment back up, which Juliana says dates back to 12,000 years. We were then able to divide that into 11 packages, which corresponded to different geological time. We found it so interesting that we could have come in contact with 12,000 years ago, the organic material, the life, the death, the decaying. Again, we still didn't know what we would do with it, but we packed it up and brought it back to Denmark. And then we had an exhibition coming up at a glass museum where it was also an open-ended research with the glass blowers.
IEO as well. All of those Spanish organizations playing a key role in this edition.
So one of the days we just told the glass blower, Chris, we said, well, we have this 12,000-year-old sediment. Maybe we'll dry it up, make it into some powder. Can you put it in the glass and see what happens?
Last year in July, we took delivery of our new.
What we are doing now here, we are basically trapping in the glass geological processes that is invisible to our eyes. This is something that occurs inside the magma chambers. So you are basically freezing in time geological processes which is impossible to see.
Brilliant relationship between.
You're basically God.
My colleagues
yes,
who were
you are.
leading the build from our side.
You have the planet in your hands.
The ship was built and delivered.
We learned from the scientists that a lot of the sediment falling down is from the water column, is organic material, also comprised of silicate. All of the algae or the shells, crustaceans, their shells are silicate, and silicate is the main component of glass. So is there a connection between the living species and a rock formation like glass? And are we connected as such as living to the geological time as well? That gave such an insight into the connection between the living and the soil that we come from.
Just to tell you a little bit about JPI Oceans, who we are and what we do. So we're a pan-European.
This sample has not been dried, so it's still wet. Still have the bottom water. Still have the water from the ocean. And then what we did, we just put it in a sort of capsule, in a bubble. So the water basically evaporated, and then it was expanding, and yeah, we were very lucky because the glass didn't break. I even don't know how to explain it, actually. Never saw this. Yeah, physical processes for real, encapsulating Arctic water in a glass bubble.
Right.
To address.
That's what we've done.
Sounds crazy.
Challenges.
Yeah, it's really
The European
It's really
Commission
interesting.
is an observer member, of course.
And I'm going to bring some of those samples back. In the lab, we are going to measure those samples, so we are going to understand which is the composition of this new material which has been created today. And I'm thinking how, for example, what we have done today can be repeated for scientific purposes, not for art, but for making scientific experiment to understand what is happening to this mineral.
Since we were established in 2011. And you can see the range, starting off with actions from the early days on ecological aspects of microplastics, and that action has just come to completion. The second round of projects was just...
We should try to understand if the minerals which we have used to prepare those glass cores have changed in composition, for example. So that's why we should do some scanning.
And again, I'm not going to list all of these, just to note two new joint actions at the top there, which have just been approved by our management board, one on blue carbon, integrating blue carbon.
Juliana's research is very interesting in exploring these life in extreme environments, which I think for us philosophically gives a really nice humbling to our own human perspective. To be able to come into contact with this kind of deep time is very interesting. If you put your arms out, the edge of your, very edge of your the fingertips, your nails, that is human existence. So the planet has been around for a really long time. Species have evolved, species have gone through multiple extinctions, multiple climate changes. For us humans, it's maybe the first, and so that's why we don't know what to do.
AMR and antimicrobial resistance and water JPI were all involved in supporting the development of an ERONet, which was funded through the Horizon 2020 program, which supported the Horizon. So ERONets, as you know, bring commitments from national funding agencies from the top up from the Commission, and this was a really important one on aquatic pollutants, as I say, supported through Horizon.
Being inspired by the scientists and their research, we learned that facts and compartmentalizations or categories are arbitrary because everything spills into each other. Can we get to a full picture of what the world is through science, or do we need to also take care of the relationship to it to get that that image or that connection to the natural world around us?
We really like working in the intersection between arts and science, because learning about, through scientific knowledge, that we share more DNA, for example, across species. We can use that as a metaphor to maybe think differently, or the fact that mushrooms have 28,000 genders. We can maybe use that then in queer politics and queer theory to again question what is this obsession with thinking binaries and dichotomies, and what is natural and what is normal. So for us, we really like working with the natural sciences to use that as metaphors for us to think philosophically.
Looking at the risk, assessing and managing the risk of determined contaminants of emerging concern.
This has changed the way in which I see the geological processes that I'm observing. I was used to see them like numbers to obtain. I think now I'm more sensible to what I'm observing. I think I will be more careful also in taking my samples, because every time that we take a sample, we destroy, we damage, we touch, we take away. When I see the Arctic C4, I see it differently. But, and I don't know why, maybe this is very stupid, but I look at it with more respect.
Just to give you a
I thought that what I was observing was an expression of geological processes, but now I see as an expression of some artistic processes also. This is something that has changed, and maybe there will be other things that I see different in the future. I don't know yet. I'm happy to discover it.
So that's just a very brief introduction on that particular initiative, the ERONet, and the projects associated with that, and JPI Oceans and the other JPI's role in kind of coordinating the national funding agencies to contribute to this really important topic. With that, I will close my introductory messages, and I'm going to introduce now our first speaker. So So actually, before I do that, Bruno, I will just give a little bit of update, particularly for those who weren't here this morning, in terms of how the session will run. So we have an hour and a half approximately for this session, same for the second session this morning. And we will also be using the empty chair approach as well to engage audience participation. So we'll hear from two of our speakers first. They'll give their 10 minutes or so presentations. We've reasonable time windows, so we won't, I feel I don't need to be too strict on the time, but 10 minutes or so presentations with slides. And then we'll invite those two speakers and the three additional panelists to take the stage. The three additional panelists will each then have an opportunity to say a few words. I'll put a question to them. They can say a few words on the areas, their expertise in the work that they're doing, and I'll introduce them first. Then we'll start the panel discussion and questions and then we'll open the floor to. So those of you who are interested, the audience, want to come up, have a question, have an interaction with the panel, and then step down again, please take the opportunity to come up and sit in the front row and occupy the empty chair. So that's how we'll run, and we'll finish at 4 o'clock. So, sorry, without further ado, then I'll introduce our first speaker, who is Bruno Gonzalez Zorn. Bruno is professor and head of the Antimicrobial Resistance Unit.
Working with time as a concept, it becomes very apparent that time needs a historical gaze to be perceived as the time we know it now, as past, present, and future. It's very difficult talking about a Thursday 1,000,000 years ago. That's an abstract format, and that's really interesting when it then comes to deep time. The impact that we are doing now happened so fast, but then also what are we a part of, actually?
And how can looking at and reconnecting with deep time, can that help guide us into maybe different directions into the future? Can it maybe excite us? Can it maybe calm us? Can it maybe scare us? What can we learn from it?
The next 10 minutes or so, my idea is to give you like an overview. Although Neil told me I could be half an hour. But I will try only in 10 minutes to give you like an overview about...
Last summer, we were invited by an art historian called Michael Kjær. He was invited onto a Norwegian scientific cruise where he wanted to basically observe artists and scientists working together to explore what kind of knowledge and experience can that intersection create.
1,000 million people on Earth, and that's a lot.
Historically, artists have been on these types of cruises quite a long time, with abilities to draw plants or draw animals. But this is in some ways a new way to work together, because we're exploring as they're exploring as well. So we are not translating what they find into an aesthetic or visual representation, but are trying to conduct our own aesthetic research with them as well.
All these aquatic animals are colonized outside my body.
Oh, there's a bunch of good stuff here.
So when we are a lot. We are not a lot. Each one of
I still remember when we met very clearly, because it was these two artists invited to join a scientific expedition. I have been at sea many times, and I know what does it mean to be on a boat, and this boat particularly, because this is a big boat. There are a lot of decks, there are a lot of corridors, a lot of cabins, and a lot of instruments, and you get lost very easily. They were curious about what we were doing, so what the scientists were doing, and I was very curious to know what they were doing. And we met there. I think it was our curiosity and also the will to really discover something else. For example, I was showing them the plankton net. You can take samples of organisms from the water, and then I show them the instrument that I generally use, which is a gravity corer, which is a long cylinder of steel, and we use it to bring up the sediment from the seafloor. I'm interested in going back in time and see what has happened 10,000 years ago, 20,000 years ago, and so on. And they were interested to know how these sediments can tell me the history of our ocean.
So there's a constant fight on Earth.
We were lucky enough to get 217 centimeters worth of sediment back up, which Juliana says dates back to 12,000 years. We were then able to divide that into 11 packages, which corresponded to different geological time. We found it so interesting that we could come in contact with 12,000 years ago, the organic material, the life, the death, the decaying. Again, we still didn't know what we would do with it, but we packed it up and brought it back to Denmark. And then we had an exhibition coming up at a glass museum where it was also an open-ended research with the glass blowers.
Efficiently and forever to fight bacteria with antibiotics. Because they are smarter than us and they have been learning much better.
So one of the days we just told the glass blower, Chris, we said, well, we have this 12,000-year-old sediment. Maybe we'll dry it up, make it into some powder. Can you put it in the glass and see what happens?
We discovered penicillin.
What we are doing now here, we are basically trapping in the glass geological processes that is invisible to our eyes. This is something that occurs inside the magma chambers. So you are basically freezing in time geological processes which is impossible to see.
So Fleming had us to discover to
yes, you are.
And I hope that from today on,
you have the planet in your hand.
Is that the greatest discovery in human medicine is the discovery.
We learned from the scientists that a lot of the sediment falling down is from the water column is organic material, also comprised of silicate. All of the algae or the shells, crustaceans, their shells are silicate, and silicate is the main component of glass. So is there a connection between the living species and a rock formation like glass, and are we connected as such as living to the geological time as well? That gave such an insight into the connection between the living.
But this is for another day. And I also agree, because there may be a vaccinologist here, that vaccines also helps to make this, okay? So it's antibiotics for all of us, and for some others also vaccines, but not much. Yes, and potabilization of water. And potabilization of water. So these three things, we know it because it's calculated, were the most important interactions of humans to have this disaster. And the fact is that we started to control bacteria. We started all the surgeries, everything we do in our hospitals is possible because we control bacteria. And here I put as an example the Spanish Transplantation Society, because it's the best one in the world, you know. So we don't only have Real Madrid and Rafa Nadal. From time to time we do other things also good. So this transplantation, the medicine, and so these kind of things were only possible because we started to control bacteria. And to make a long story short, the fact is that it was not very difficult to discover all these antibiotics. So there was the golden era. In the 60s and 70s, we discovered all antibiotics that we have today. But the fact is that there we had already enough antibiotics. It's true. So for every disease that we had, the prescriber could prescribe 2, 3, 4, 5 antibiotics that worked perfectly. So the industry decided, okay, this is done. We have enough antibiotics. Let's concentrate on other things. On what things, for example? For example, HIV treatment. And that was a good idea because HIV in the 80s, many people, I was not born, but some of you, yes. But in the 80s, many people died because of HIV. And today, the life expectancy of a person with HIV is the same that was somebody without HIV. And that in the 80s was impossible. So I will not blame the pharmaceutical industry to have switched to other molecules because for many things they did well. But the fact is that they concentrated on other things, and it's 30 years that we have not discovered any new family of antibiotics. So today, because the bacteria adapt so well, we have a lot of resistance, but nearly none new antibiotic in the market, in the pipeline even. So we used, because we liked it, to use antibiotics in animals, in humans, and in the environment. I'm in favor of using antibiotics in animals because animals, from time to time, they get ill. They can get ill. So as, for example, we raised our children in our half-sterile apartments in New York or in Madrid, and even so, they get bacterial infections. So it's impossible, I think, to protect a population of animals from bacteria. So they get disease from time to time, and we have to use antibiotics to treat them. So I'm in favor of it. And we use them in humans and all of them. But the fact is that we have used them so much that I think that this figure is right. We have used them so much, and most of the antibiotics, they don't stay in the patient. Most of the antibiotics are secreted actively from the patients. For example, as you remember very well, the first patient that was treated with penicillin, the urine was taken out from the patient, the penicillin re-isolated and put again in the patient. So that because it was difficult from the fungus to isolate, it was producing so little penicillin that it was very hard to isolate it from the fungus and the plate. So that gives you an idea that really active molecules are secreted all over when we treat patients, any patients, humans or animal patients. And then you will say, well, maybe we know we master more or less that there's a problem with the resistance, and maybe we now control this, but we don't. As you see, the antibiotics that we use on Earth is increasing. It's not increasing in Europe, but it's increasing in the rest of the world, because the low and middle income countries want to have more health, and because they want to have more health, we are constructing hospitals, and because we are constructing hospitals, we are using more antibiotics. And at the same time, these 8,000 million people also want to eat like you and me. I mean, they want to eat. They are fed up in Africa, South America, whatever, to eat things that they don't like. They want to have some protein with chicken, whatever, and so on. So it's increasing for the production of animals and for us, the use of antibiotics in humans. And this is how you see how an antibiotic resistance gene can spread, like a coronavirus, like whatever. So you see a gene that is we had there in India, and suddenly it spreads all over easily in a few seconds. In 2014, there was this guy, Jim O'Neill, that said, okay, if we don't do anything, by 2050, 10 million people will die because of antibiotic resistance. 10 million people by 2050. The fact is that, so it would be the first cause of death. The fact is that today we know that it's more. It's 1.2 million deaths per year. So it has increased. And it's even worse. As you can see, these are the maps that we do of antibiotic resistance. So antibiotic resistance is fully out of control, but with COVID, it is even worsened. Because with COVID, although it's a virus, we treated our patients were in our intensive care units and got more hospital infections, and we had to use more last resort antibiotics. So Jim O'Neill said in 2014, if we don't do anything, but we didn't know that pandemic that we were going to have, so my prediction is that we will have 10 million deaths by 2040 and not by 2050, because it has accelerated a lot this real problem. So how to preserve the antibiotic action? So in the WHO, we do different things. We classify the antibiotics, and we try to reserve some antibiotics exclusively for humans, some are exclusively for animals, and like that, we try to compensate and to use antibiotics in animals, but they don't cause really resistance in humans. There's one possibility, but there are more. The fact is that we know, as I told you, that these antibiotics don't stay in the patients. They go to the environment, they go to the sewage, they go to the water, and they flow in this ecosystem in what we know, like our One Health context that we know very well. That has an advantage, because you could say this is a disaster, but at the same time, this means that we have very different points of action where we can interfere in antibiotic resistance. Because these bacteria flow and the antibiotics also flow, we can have interventions in wastewater, in rural water, in the sea, in the animals, because we know that this is like flowing. This is like not the good news, but it's a bit the good news. It's not only a problem of hospitals, it's a problem of all of us. And we don't have many data of what is happening in the environment. So we know, so people working with human health or animal health, we know very well for many years that we use antibiotics, antibiotic resistance, and so on. But it's only lately that we have put the environment into this really important issue. And there are not many data. This is, for example, metagenomic data. So to see what resistant bacteria we find in wastewater in the world, and you can see that all over, but especially in some places, Southeast Asia, Africa, and here we have a lot of resistant bacteria, maybe more than in the rest of the world. And we have done a study in Ghana, for example, and in wastewater of hospitals. So to make a long story short, the wastewater of hospitals in Ghana is full of pan-resistant bacteria. So you have resistance, multi-drug resistance, and pan-resistance. And pan-resistance is resistant to all possible antibiotics. And these come out from the hospitals in Ghana, where they use many antibiotics. And the problem is that this is the wastewater. The wastewater of the hospitals in these kind of countries is surface wastewater. So it has an access to all animals, to humans, and then goes directly to the sea. And there are not many data that we have in the sea. This is the only publication that I found from my friend Thomas van Berkeley. And here you see the contamination. This is here he has analyzed the resistance levels of the fishes that are hunted in these regions. And you see with a very low uncertainty that in these regions where we use most antibiotics in the world, we also have most resistant bacteria as pathogens and as colonizers of the fish that we fish. So there is really a flux of these antibiotics and resistant bacteria to the fish that are swimming outside there. And we are all going to die, but despite so, I'm optimistic. So I think that we know now very well that there is a direct flux of antibiotics and pathogens and bacteria between humans, animals, and the environment, and that we are starting to work from this One Health perspective. And we are going to discuss. So I think that we are seeing a new light, a new way of how we are going to address this, and that I'm sure that together we will manage. And with this, I wanted to thank you for your attention. Thank you.
Thank you so much, Bruno. I think you've really set the context for this session. You've outlined the scale of the issue, which I think most of us in our normal lives are aware of in terms of antimicrobial resistance and the issue around the production of new antibiotics and the lack thereof. But clearly, where there might be at least some understanding of the scale of the problem in that regard, when you get to impacts on the environment, we really do lack that information. So it's a really good way to just kick off the session with that very thought-provoking presentation. Thank you. So we'll move now to our next speaker. She is Marika Mezzolani from the University. Marika is a postdoctoral researcher at the Polytechnic University of Marche, Italy. Her research focuses on pharmaceuticals as emerging contaminants in marine ecosystems, and she is also manager of the pharmacy project, which we saw listed earlier. And Marika will talk about the presence, behavior, and risk assessment of pharmaceuticals in marine ecosystems.
Thank you for the introduction. I would like to thank the EurOCEAN Organizing Committee for inviting me and for giving the possibility to speak about the pharmacy project. Pharmacy is one of the 18 projects funded by the Aquatic Pollutants ERANET 2 years ago. Our consortium gathered 5 different institutions in Europe: the Polytechnic University of Marche, which coordinates the project, University of Heidelberg, Stavanger, University of La Coruña, and the Spanish Institute of Oceanography. The main objective of the pharmacy project is to study the presence, the distribution, and the effects of pharmaceuticals in European coastal areas, to finally develop an integrated risk assessment procedures for evaluating the risk of such compounds in marine organisms. Pharmacy research activities are organized in 5 different but strictly interconnected work packages, specifically aiming to perform the first qualitative and quantitative characterization of pharmaceuticals in European coastal areas, but also to study, to investigate the ecotoxicological potential of pharmaceuticals in marine species. The final objective will be to develop an effect-based risk assessment procedures, which could be helpful to support the implementation of relevant European Union policy. An important aspect of our project is a strong connection with our stakeholders community, including scientists, of course, but also regulatory bodies, private companies, and citizens, in order to magnify the impact of our project results, to promote a participative approach, but also to increase the awareness on this important environmental issue. Talking about the first work package, we perform different seasonal sampling campaign over a wide geographical scale, covering part of the Atlantic Ocean, the North Sea, the Western Mediterranean, and the Adriatic Sea. We decided to select different typologies of sampling sites: wastewater treatment plants, outfall, estuarine areas, pristine and touristic sites, collecting seawater, sediments, and species belonging to different trophic levels, including those of commercial interest. Considering the lack of existing procedures for measuring pharmaceuticals in environmental matrices, the development of harmonized protocols for detecting pharmaceuticals in seawater, sediments, and marine species represented one of the major challenges of our project. This process is still ongoing, but preliminary results allow us to characterize the presence of more than 50 pharmaceuticals in seawater, and also to document the accumulation of antiepileptics, psychiatric drugs, anti-inflammatory in wild mussels collecting along European coast. Moving to the WP2, in order to properly address the adverse effects caused by pharmaceuticals under laboratory conditions, we performed different in vivo, in vitro, ex vivo studies, selecting different key bioindicator species, early life stages, cell lines, and tissue slices. We tested environmentally realistic concentration of more than 20 pharmaceuticals, studying their effects both as a single compound, but also as pharmaceutical mixtures. Finally, we would like also to understand, to investigate if and how pharmaceutical toxicity could be modulated by additional environmental stressors, like, for example, climate change related parameters. For this reason, we set up laboratory experiments combining pharmaceutical exposure with a decrease of seawater pH or under a marine heat waves scenario. Without going into details, overall results highlighted the capability of marine species to accumulate pharmaceuticals, but also to eliminate them when they are maintained in clean seawater for a couple of weeks. All tested conditions determine the onset of adverse effects from molecular, biochemical, cellular, up to organism level. Overall results suggested how this approach can be useful not only as a diagnostic tool, so for measuring the adverse effects in laboratory or field condition, but as also a predictive instrument that possibly in the future could be used, for example, by pharmaceutical industries who would like to test the environmental sustainability of new drugs before they are released on the market. The main objective of the WP3 is to develop an environmental risk assessment procedures for pharmaceuticals, allowing to summarize a huge data set of complex scientific results into a user-friendly format that can be easily understood by non-target, non-expert stakeholders. So to do that, we basically collected the results and integrated the results from laboratory studies and field investigation and applied a weight of evidence approach. So we elaborated these results through weighted criteria, which consider, for example, the toxicological relevance of analyzed responses, the magnitude of variation compared to specific thresholds or control condition, for providing for each typologies of data, chemical analysis, bioaccumulation, biomarkers, and so on, a specific hazard index before the overall integration in a risk index ranging between absent to severe. So we basically elaborated results from laboratory experiments, and applying this approach to us was very easy and simple to communicate, for example, that a chronic condition caused the onset of adverse effects ranging in a level of risk which varies from slight to moderate. This level of risk decreased at the end of the depuration period when organisms were maintained in clean seawater. Considering the effects at organism level, we observed that acute toxicity is not always occur, or better, lower acute toxicity of pharmaceuticals compared to the chronic toxicity. And also usually higher level of risk was measured for species exposed to pharmaceutical mixture compared to those treated with single pharmaceuticals. As I mentioned before, an important part of our project is represented by the strong connection with our stakeholders, including, of course, the scientific community, but also citizens. Besides participated to conferences or dissemination events, we decided to develop specific surveys targeting scientific community and also citizens. The survey for citizens, for example, allow us to better communicate our results, but also to suggest some mitigation strategies to reduce pharmaceuticals release in marine ecosystems. All this information can be found in our website or social media, where you can always find also the last update from our project. Last May, the pharmacy project was evaluated by the aquatic pollutants reviewers, and according to their opinion, one of the major strengths of our project is the strong connection with private companies and regulatory bodies, which is essential to us to realize the circular knowledge approach, which represents our mission, meaning that knowledge produced by scientific research is extremely useful not only for citizen education, but it can be useful in the future for pharmaceutical industries who would like to test their environmental sustainability of new drugs before they are released on the market, or in the future medical doctors could have the possibility to prescribe among a different panel of active principles with the same therapeutic effects, those which are more environmentally sustainable. But also wastewater treatment plants operators or companies dealing with the water supply can invest in new technologies to produce safer and cleaner seawater. Finally, the effect-based risk assessment procedures could be helpful to regulatory bodies for the implementation of relevant European Union policies, like, for example, the Marine Strategy Framework Directive. I would like to thank the aquatic pollutants, GPIs, our national funding agency, the entire pharmacy consortium, and all of you for your kind attention. Thank you.
Thank you, Marika. And again, a really interesting presentation. I think the work that you're doing in pharmacy is very much at the coalface of the issue we're addressing here, which is looking at those pharmaceuticals and contaminants of emerging concern that are in the environment, in the marine environment in this particular case, but also the risk assessment and how you communicate that and transfer that risk assessment to policymakers. And I think your last point about the engagement and involvement, I should say, of the private sector and regulatory bodies is also critical, because these are the key stakeholders that need to be involved rather than science working in isolation. So I think that will come up again in our discussions. But thank you very much for your presentation. Okay, we'll bring now the rest of our distinguished panel to the stage. So I'll ask them already to come up on stage, and while they're coming, I will introduce them. So Kelly Thornber is a research fellow in sustainable development at the University of Exeter in the UK. Kelly is co-director of the Pharmaceutical Pollution Solutions Hub, and we'll hear a little bit more about that. And her expertise focuses on developing solutions to address pharmaceutical pollution and antimicrobial resistance in aquatic environments. So welcome, Kelly. So next is Nenad Gligoric. Nenad is founder and head of research of Zentrix Lab. He specializes in cutting-edge research and the application of ICT in addressing the Sustainable Development Goals. He leads the research activities of the company and develops solutions for water and air monitoring. And he is involved specifically in the Horizon Europe mission project, IIM-CSIC. Welcome, Nenad. And our final panelist is Taina Garcia de Fonseca. So Taina is a researcher at the Center for Marine and Environmental Research, or CEMA, at the University of Algarve in Portugal. She has a PhD in marine pollution and ecotoxicology, and her research focuses on the effects of marine pollution caused by human pharmaceuticals on marine organisms. So that's our full panel. Of course, Bruno and Marika are part of the panel also. We will jump straight in now with some questions for our new panelists. And then we'll, of course, just develop the discussion out from there, including the empty chair. So I'm going to start with you, Nenad. So we'd like to hear a little bit about your work, but in particular, the project in which you're involved in, iMermaid, aims to find innovative solutions for monitoring and detection of chemical pollutants. Can you explain what are the challenges in that regard in the case of pharmaceutical pollution?
Yeah, thank you very much, Neil. So in general, iMermaid is a Horizon project that targets different chemical pollutions beside other also pharmaceutical pollution. So this is a lighthouse mission project that targets monitoring and remediation, and of course biomonitoring approach to cope with the problem. What we experience in the project and in general when looking from the scientific perspective, what is available at the moment is the significant number of pharmaceutical available in the Mediterranean Sea. So from different manuscripts, we realized that there is more than 40 pharmaceutical available that can be found in most of the countries. And there are some countries that are basically lacking data because of lack of funding or some third-party reasons. So if you think that there is 40 compounds, you need to start from somewhere. You need to detect them all. So you need to down select basically because the cost and the infrastructure and everything that needs to be provided is very expensive and time demanding. And there's also some of other compounds that are unknown with the impact to biota, such as salbutamol or hormones and a number of others that we do not know how they impact actually the flora and fauna. This is why you need to be, let's say, strict and to be able to start from down selecting to the one that are most important, and not only because of Bruno had such a nice presentation, but antibiotics are one of the most impactful. So it's the best approach to start from that point. But the most problematic part is the dilution of pharmaceutical from the sea and upstream. So if you, let's say now, try to monitor and you for sure know that the water is polluted in the sea, frequency of detecting it is around 60%. So meaning that even there is pharmaceutical, it's very hard to provide sensors that are able to detect it. And there are also problems with calibrations, problem with the cost if you need to deploy it in low-income countries, and so on and so on. So I hope I just opened the floor well. I can speak more, but I would like to leave some time for the others. So from my perspective, I would close it with this. Just the last sentence would be about the problem of detecting the chemicals that influence also by the matrix factor, which means that if you have in one sample also other compounds, it can infer the accuracy of the sensor. So it's a very, very hard topic at the moment, but hopefully we will have at least a couple of these pharmaceutical being detected in the project.
Thank you, Nenad. Is it very interesting just to hear, I mean, you're coming at it obviously from a perspective of the technology we need and developing the sensors and technology we need in order to be able to measure this problem. And, you know, it clearly is a really important component of the solution and to understand at least the scale of the problem. I'm sure we'll come back to that. I'm going to move now to Tina actually next. So Tina, your work as an ecotoxicologist, you're looking at sort of the impacts of pharmaceutical pollution and developing methodologies to do that. In your experience, what are the most important knowledge gaps that you need to consider based on the work you're doing for the future?
Thank you for the question, Ayo, and for the introduction. Good afternoon, everyone. And thank you for inviting me to be part of this inspiring discussion panel. Well, one of the crucial lessons that I learned from my past years working with marine ecotoxicology and marine pollution by pharmaceuticals is that this is not only a marine issue. Actually, it starts on land and particularly in our own houses. So the pharmaceuticals, they are molecules, synthetic natural chemicals that are used to prevent or to treat a disease. And they are biologically active molecules that have a proper molecular target, mechanism of action with a purpose to have the desired therapeutic effect in our bodies. And afterwards consumption, these medicines, whatever therapeutical class that we use, painkiller, anti-inflammatory drug, antibiotic, it will be absorbed, distributed, and metabolized in our organisms, in our liver, kidney, intestine. So afterwards that, it's going to be excreted by our urine and feces with different types of metabolites, or even also as a parent form of the drug, which means it's original form of the pharmaceutical. So it depends a lot of the molecule that we are ingesting, consuming. And sometimes when we have this pharmaceutical and we have the therapeutic effect, we say, okay, it's done. But after flushing the toilet, we have a very long journey through the waterways until the wastewater treatment plants, if they exist, which is not the case from the country that I came in Brazil. We still have this problem, and many other countries, as Bruno showed, like in Ghana. And so we have, as everyone knows, concentrations that range from nanograms to micrograms in coastal water, estuarine water, drinking water, groundwater, and so on. And despite for many of you, it may sound like it's very trace and low concentration. I have bad news, because working with marine ecotoxicology, we deal with the effects in the laboratory, doing bioassays, as Marika also showed here. So we assess cytotoxicity, effects in invertebrates or vertebrates. In my case, I work with marine mussels, I work with marine polychaetes and sea urchin as well. So we have a different range of biological effects, including DNA damage, membrane damage, the disruption of enzymes. So we know already that these small concentrations are causing harm and a potential risk for these species, which are very representative in an ecological way, but also in a very economical way as well. So one of the lessons that I learned a lot also during my PhD that I concluded in 2019 is that when we have the aquatic environment, we have many types of pressure acting together, and particularly also the combination of different therapeutical classes, metabolites, parent drugs, different concentrations, different emerging contaminants, different persistent legacy contaminants. So the scenario is much more complex than just exposing the lab to one or two drugs. So we also performed some exposure with mixtures of pharmaceuticals, and we realized that exposing treatments of mixture of anti-cancer drugs, 3 anti-cancer drugs in each of the treatments at an increasing concentration, we could realize that the lowest concentrations were causing the most impacts in the marine mussels and in the development of sea urchin. So working with pharmaceuticals, we have these kind of surprises as well, because the mode of action and the interaction between them will not be something predictable when we work with individual stressors. So it's important to also think about the combination of all of them. And also we don't have like the dose response does not work at a monotonic dose response, which means a dose response that increases the concentration, then you have, so does the effect. In this case, we have very low concentrations causing the most of harm. So pharmaceuticals are a very tricky kind of contaminant. So despite all the biological effects, we also have the bioaccumulation, biomagnification, and in the end of this food chain, humans consuming, and what are the effects, what are the risks. So we still don't know exactly what will happen, and this is part of my current research as well, to evaluate the bioaccessibility in the human organism after the consumption of this recontaminated seafood. And we can talk a bit more about this. Thank you.
Great, thank you, Taina. So I think your intervention also really gives an indication of just the level of complexity that we're dealing with. So, I mean, it's one thing to understand which contaminants are there, which pharmaceuticals are in the environment, and then to start looking at the impacts that they might be having on different ecosystem components. But then you, as you say, you can't look at each one in isolation. These are cumulative and combined effects that have different, and you know, the level of complexity of the challenge becomes clear. And then I think the other sort of complexity, and I think you've also opened this discussion, and I know our next speaker, Kelly, will pick this up, is the complexity of the challenge in terms of finding solutions. So, you know, one of the discussions as a panel, we, like I think all of the panels for the conference, we met as a group online before we came to Vigo to discuss and plan the session, and to just get a good picture of the different presentations and how we can, you know, have a really useful discussion. And I think, Kelly, you were the one who raised the point about, look, this is very much a marine science conference, of course. We generally will have the ocean science community in the room. But, you know, the problem that we're dealing with in this of pharmaceuticals in the marine environment is not just in the marine environment, it's in aquatic environments, and the origin and the sources are land-based sources. So, you know, to be clear, if we're going to address this problem holistically, we need to be looking at all components of the problem so we can address all components of the solution, or potential solutions. I don't want to be trite and say there's easy solutions. There clearly is not. But in any case, I think that's a good segue. Sorry, Kelly, probably saying too much. I'll let you do the talking for your intervention, Kelly. So you're going to tell us a little bit. You're at the European Centre for Environment and Human Health at the University of Exeter in the UK, and you've developed something, or established, I should say, something there called the Pharmaceutical Pollution Solutions Hub. So can you tell us a little bit about that and how you address this problem?
Yeah, thank you. Yeah, and thank you very much for inviting me to share, talk and be part of this discussion. So, yeah, I think if you want to address pharmaceutical pollution from a holistic point of view, you need to look at the societal drivers that are causing pharmaceuticals to get into the environment and have environmental impacts. And these are social, cultural, economic, political factors that are really causing these compounds to get into the environment. And because this is where the solutions are. And this is where I come to with so it's called the Pharma Pollution Hub. And it's a new non-profit organization that we've set up, and it's dedicated to finding solutions to reduce the environmental impact of medicines used in human healthcare. And particularly it's UK focused, but of course, the UK isn't in isolation. So what we're doing in the hub is we're bringing together stakeholders from across the pharmaceutical life cycle. So because pollution happens at all stages of the life cycle, we have manufacturing pollution. So we have stakeholders from the pharmaceutical sector. Then pharmaceuticals go into healthcare, of course, and there's a huge amount of wastage in healthcare. There's excretion from patients. And then there's disposal, inappropriate disposal. There's wastage at all these stages of the life cycle. Then when pharmaceuticals get into the environment, they have impacts. We don't monitor enough. We don't manage enough. So what we're doing is bringing together stakeholders all the way from the design and manufacture through to healthcare, through to the environment, and bring them together to develop solutions together. And we're using a systems thinking approach for this. And systems thinking approaches accept that this is a complex problem. So as I discussed before, there's a whole range of societal factors that are driving pharmaceutical pollution. And so this is complex, it's deep rooted. So our use of pharmaceuticals has evolved, our healthcare systems have evolved to rely on pharmaceuticals. Bruno talked about the reliance on antibiotics. This is deep rooted. We can't reduce pollution that easily. We have to accept this is complex. And so when we develop solutions, they have to acknowledge and work with this complexity. And then the Pharmaceutical Pollution Hub is, we're doing three things, basically. So the first thing is understanding each other's needs, understanding the situation. So, you know, when you look at this from a holistic point of view, there are conflicts of interests, different needs all over the place, trade-offs. This is complex, but we have to understand each other's needs and interests if we want to move forward. So that's the first thing we're doing, is understanding the situation. The second thing is together identifying a strategy. So we're looking at where we are, where we want to get to. So by developing a strategy together, we can develop solutions that work for as many people as possible, and deal with the trade-offs and, you know, try and make this work. So and the idea is that this is a complex system. If we want to make substantial change, this system has to evolve together. So we have to have a coordinated approach so that everybody's bought into, and it has to evolve. So that's the second thing. So we're identifying where we are, where we want to get to, and then finally we're supporting people to get there. So what we come up against a lot of the time is people either, or everybody wants to do it. Nobody wants to pollute the environment, but people either don't know what to do, or the challenges involved are so substantial that in the short term that there's too much risk, economic risk, reputational risk, all sorts of different types of risk. And so we are mobilizing the research community to work with stakeholders to try and sort of help use research to help them make change quicker. So things like identifying solutions, prioritizing solutions, testing, modeling, evaluating. This is all applied research. So we're trying to link up the academic community to support, when I say external, I mean non-academic, so industry, government, civil sector, and that's what we're doing. So they're the three things, and I'll stop there.
Brilliant, thank you, Kelly. So I think you're taking a helicopter view of this problem, in a sense, in your work, and trying to kind of really look at how we bring the different components, different communities, different parts of the challenge together to take a holistic approach to solving, you know, all these problems. I'm going to just ask a kind of maybe a simplistic question, maybe to kick off the broader discussion. And I apologize to the panel, because I'm going to go a little bit off piste from I do want to come to research challenges and gaps, absolutely, because we are in that community here, and this conference is about looking at, you know, where do the scientific community and scientific funders and all need to be placing their efforts and their investments going forward. But listening to all of your presentations, at times it's hard not to become alarmed, okay, not to be really concerned about the scale of this issue, the complexity of this issue, and the potential or not that we have of even trying to address it. So what I want to ask you now is, you know, and again, just setting aside the research gaps and challenges for a minute, is it a solvable problem? What are the areas that we can actually take action to address this issue? You know, is it because we need many of these drugs and pharmaceuticals to address human health issues? Is it bioremediation? Is it new types of drugs? What are the solutions? And this is before we even get to, you know, stopping some of these compounds getting into the system. maybe just to open up that very broad question of where are the big areas that we might be able to make change and find solutions? And I'm just going to open that up to the panel broadly and see if any. Kelly, do you want to start us off, and then maybe I'll ask some of the others to see if they come in.
I'll start. There are loads of solutions to start with, you know, but there are solutions from the sort of low-hanging fruit, which is sort of easy, low impact usually, and then you get the big solutions, which is the, you know, the tree roots, if you like, which really need, if we really want change, we have to accept we cannot, the way we live our lives at the moment is not sustainable. The way our healthcare system is not sustainable. And so we need to accept changes. We need large scale change. Now, that doesn't mean it can't happen. It just means that we have to have, you know, coordinated support and from the public, policymakers, everybody. One of the things, and I'll leave the sort of technical solutions to others, but from a systems perspective, because that's what I've been doing, there's a couple of things that come up when you look at this from a systems perspective. One is that there's a lack of feedback from the environment upstream. So things like decision-making processes in the healthcare sector don't even think about the environment at all. They think about clinical effectiveness and economic, you know, cost. So there's no feedback. The environment isn't coming into this at all. So that's one of the things, the solutions is we need to integrate this into decision-making. And that is in itself quite challenging, but possible. The big ambitious solution is, so from a systems perspective, the more pharmaceuticals that are going into the system, the more that come out into the environment. And so we need to reduce the amount of pharmaceuticals we're using in the first place. And and this comes to public health, because more, at least in the UK, and I think it's probably similar across Europe, our healthcare systems are more and more treating the problem rather than preventing the problem. And that's to do with investment and all sorts of other issues. But actually, if we invest more in the what's called social determinants of health, so things like, we know that up to 80% of a health condition is not caused, well, at least in high-income countries, is actually caused by, you know, education, housing, you know, the social side of things. If we invest more in that, we reduce the need for pharmaceuticals, so we reduce the amount of pollution. So sorry, I know this has been a long answer. So, but the key is the pharmaceutical industry is so influential here. We can't just take money off them. They're too influential. We need to work with them and say, how can we help and support the pharmaceutical industry to invest in other business models that don't involve selling drugs? So prevention and things like that. But anyway, I'll stop there because I've talked long enough.
Yeah, thank you, Kelly. I mean, it's just, there's so many issues there that we could spend an hour probably talking about alone, and you could talk on, I know, for a long period of time. Tina, did you want to come in on this point?
Well, I
think it's on.
Okay. I will also cite what Anastasia said in the first session. She said 3 words: collaboration, collaboration, collaboration. And I really think that is also the first step for the solution, because we really need projects now, making the link with your first comment about the research gaps and the funding. We really need projects that start to connect different expertise and specialities, because I work as ecotoxicologist and I assess the impacts and all that. I do the monitoring, but we also need other expertises to give other kinds of support as well, such as the healthcare professionals. We also need the speciality of technology, because we need nature-based solutions, innovative technologies to remove these pharmaceuticals before they reach the aquatic environment. We don't need to wait them to reach there. We just need to close the tap, and we need really to work together. And another comment regarding your other question about the research gaps is that now we are facing a multi-stressor environment, as Marika was presenting, and we have the knowledge, but this knowledge is about to change, because we have many combinations that we don't know how they will actually operate in the environment. So we also need different tools, different stakeholders, trying to simulate, to predict how these pharmaceuticals and other emerging contaminants will act, not only in the biota, but also will cause any kind of harm and risk to the human health. And then we have another branch of study with risk assessment, which is not my expertise as well, but human health risk assessment, maybe it's another area that we should focus from now.
Thank you, Tina. Maybe Bruno, I'm going to ask you to come in. I mean, you spoke about One Health. Maybe I'll just let you speak. Say what you're going to say. I don't need to introduce.
No,
Go ahead.
come on. Say what you want
so
to
you
say,
spoke about One Health. It's something I'd like to maybe we could hear a little bit more about. But equally, from a solutions perspective, how much is that part of the solution, and what are your thoughts in this topic?
Yes. So normally, what can you hear me? Yes. So normally, what we say in this kind of cases is we need artificial intelligence, you know, and data management, because we have a lot of data and they have to be integrated, because like this we can predict what will happen in the future, etc. We would say we need new antibiotics because people are dying in the hospitals because we don't have enough antibiotics. We would say we have to develop vaccines in humans and in animals, because not only against bacteria, but also against viruses and parasites, because this increases the health status, and like that, there are less secondary bacterial infections and less use of antibiotics. So we will say all these kind of things, but I don't really agree with that. I think that we are really working for too long, or for many years, in silos where there's really no communication, and there's really no communication. So I work only in the field of antibiotic resistance, only in that field, okay? I have no clue of the antibiotics that she has seen that are resting in that are more in the environment, less in the environment, which are more stable or not more stable. So we know very well in my area how much is the half-time of an antibiotic in our body. So I can tell you perfectly, carbapenem, tetracycline, whatever, but we have no clue, or I don't know, but I don't know if it is known. That's even worse. I don't even know if it may be known. I know that the fluoroquinolone is very stable in the environment, and carbapenem is less, and amoxicillin is less, but we don't know really to what extent it's important that I put carbapenems in the environment in Ghana. Because maybe it's not so important, because in a couple of days it's off, but maybe sulfamycin tetracycline is there the intervention. So we really don't know, because we don't talk to each other. And that's a very important problem. And it's not only that, it's we have to include in this One Health concept, and it's the one like my fight in the last years, we don't have to include only health professionals, but also anthropologists. So we have to know that the behavior of people is extremely important. In this country that I told you that is great, 90% of the people are having an antibiotic in their houses. You know what? In Swedish, none. So there's no Swedish guy with an antibiotic in the house, and the 90% of the people, we like it, you know. But we like it anthropologically. We like it, you know. We feel like safe. We don't trust the government. We had tuberculosis until the 70s, you know. There's something anthropological that makes that all of us have an antibiotic in our house, and that we use it from time to time because we are smarter than the doctor, you know. And so anthropology is very important in the behavior. I want to when I say I tell the prescribers to prescribe differently, they don't, because they're afraid. Oh no, maybe now a patient is going to die, you know. So it has a lot of philosophy, anthropology, economy. Why don't we develop new antibiotics? Because it's not worth it. Because if you spend 15 years to develop an antibiotic, and then I would say the whole world, don't use it because we have a problem with antibiotic resistance. The pharmaceutical industry is not stupid. They're going to develop anything against diabetes and any chronic disease or whatever. So we need economists. So even if you think that there are professions that are very far away from your problem, from the ecological thing, from my patients or whatever, they are not. So it's very important to put really people together, because I do not know the problem. I do not know the research solution. It's many years that I think I know it, but I'm wrong. I'm wrong. I think that this One Health perspective is a matter of professional humbleness. professional humbleness, where you think that the solution is in your profession, you know, because I prescribe the antibiotics, I'm the smart, whatever, but it's not true, because I don't know what is happening in the fishes. Why aren't we developing a vaccine against salmon disease in Chile, but in Norway we do? You know, we have to see, maybe we have to develop a vaccine there. Maybe it's not possible. Maybe it's another system. So, but we really don't talk to each other, and it's very important. So that's why I'm happy to be here. So many things to do, but I prefer to be here because I think this is very important. But next time there should be here people maybe from completely other sectors, because I think it's crucial if we want to find original solution and not the classical that we all know from each other. So I don't know the solution, but I think that one of the bottlenecks is that we don't talk together enough, even at the scientific level. And there's then the bottleneck to the political level. We don't talk the language, they see the short-term thing, and obviously if they can act against hindering the car accidents, because next in a year they will put a medal here to say, oh yes, I've reduced by 20%, that's easy. But there's ecological things, and even the deaths in antibiotic resistance, it's slow, and they are not doing that because they are only looking for the short-term solutions. So that's a bit what I wanted to say. Thank you.
Okay, that's really interesting. I think maybe at this point we should just acknowledge and say something about the fact. I mean, what's clear in terms of your comments and everyone's comments is you know, that there's an element of working in our own, everyone in their own fields, and we need people who are disciplinary experts. Of course we do. I mean, it's not to. But that kind of crossover and cooperation between disciplines, between different parts of the scientific community, and then between those and policymakers, private sector, those are weak at the moment. And to solve the problem, we need to strengthen those. Everything that's coming out sort of suggests that this is a major societal challenge which requires a mission approach. We have a mission. We have an EU mission, Restore Our Ocean and Waters, and what's really critical, and you know, those who sat down to just design the mission at the outset understood that it couldn't just be on oceans, because many of the problems reflect interactions between coastal and inland waters and what's going on land as well. So there is a platform there. Maybe some of what we're saying this afternoon in this session can guide and inspire and inform a little bit the discussions around the next stages of the mission, because that's what a mission is about. It's saying, here's a problem, now let's bring all the best minds and components and actors together to try and address it in a holistic way. I'm going to now, there's so many areas which are just bubbling out of this conversation. We could go off down many different ways, but I do want to open up the floor. So is there anyone who would like to come up and sit in the empty chair? Sorry. Well, while we're doing that, please come to the front if you're interested in the empty chair, because Nenad you were going to say something, Nenad? So while Nenad is speaking. Oh, I'm really sorry.
10 minutes ago.
My apologies.
Well, I'm fine. I just wanted to, I will be short, I promise. So I wanted to give an overview from this different perspective. So I think when everybody's speaking here that we maybe lack of multidisciplinary data in one place, when we speaking about traceability and coming back to the source of the problem. The source of the problem is when you have a lot of prescriptions or a lot of antibiotic misuse, then you need to be able to track and trace them. And there is complete set of standards and complete set of research in this area that works around traceability of the pharmaceutical. So from the production to the end user. This can be one part of the resolution that you mentioned. So I didn't want it to go back and forth, but I would just conclude with that. So this can be solved, not the complete solution, but at least decrease of the misuse of the antibiotics by track and tracing in most of the countries. I know in Serbia I can buy anything from the antibiotic side without prescription. They just put the name of some doctor and done deal. So.
Okay, thanks, Nenad. Okay, any Rosa, please. Empty chair is all yours. I know who you are, but maybe introduce yourself first, Rosa, and then.
Thank you. Yes, well, thank you for the panel, and all your presentations have been really very exciting, really very interesting. My name is Rosa Fernandez. I come from CETMAR here in Vigo. And while you were speaking, I was thinking about demographics and how far demographics is also a key issue in relation with this matter, right? Because I was thinking that if we look at the countries where maybe the problem is heavier at the moment, maybe we are already a bit late because the population is growing very old. If you look at the trends in demographics, probably the pyramid is in a way that this population, even if I mean there are things that can be improved, but probably will continue needing medicines, drugs, because they are growing older. However, demographics are not the same in every parts of the world, and maybe there are areas where also it's not just that the demographics are not the same, but also the problem is not the same. I mean, there is still free from that much pressure from the use of antibiotics and so on. So I would like to know what you think about this, your opinions on this regard, and if maybe a prevention to at least make sure that in those areas of the planet where the problem is not that heavy at the moment and where the population is not that in that situation, maybe it could be a good idea to try to focus the prevention and the alternative way of addressing the health systems in a different way that we've done in this part of the world. I don't know, maybe it's a crazy idea, but I was thinking about that.
Please, Bruno, please.
Well, yes, I mean, I could talk a lot about antibiotic resistance, prevention, different parts of the world, what we can do, the prescribers, as you said very well, how to train the prescribers. When I was in India, for example, and the problem that is completely different in every part of the world. I don't want to talk only about antibiotics, sorry, but when I went for the first time in India, I went to a pharmacy and I got antibiotics over the counter without any problem. And then the next day I was opening the conference. I was saying, oh, because I'm smart, I will tell everyone that we just have to do prescriptions compulsory in India for antibiotics, you know, and it's easy, you know, you just do prescriptions compulsory by the government and the problem is solved. But I went to have dinner with my friends from India and they said, Bruno, the healthcare system in India depends on the pharmacies giving antibiotics over the counter. So most of the people in India don't have access to a primary doctor that can make a prescription. So the problem is complex. It must be, as you say very well, you haven't said it, but you mean it, based on and tailor-made to every different country and situation. So in India, you cannot do from one day to the other prescription only, but in Spain, we still have 5% of the pharmacies that are giving antibiotics over the counter. And in Spain, it could be a solution. So it's different tailor-made solutions because, as you say very, very well, the demographic, cultural, economic situations in every single country are different. So even in Europe, as I said, between the South and North. So imagine between Southeast Asia and Argentina. No?
Can I say something?
Just a comment, because actually the demography influence a lot also the release of pharmaceuticals in the environment, meaning that in many countries, Bruno talked about India, they do not have wastewater treatment plants, or water is not properly depurated through wastewater treatment plants. So one of the main issue is that all these information are not very bioavailable. It's something that you always said before. When we talk about pharmaceuticals in the environment, during last years, we started to develop analytical procedures for properly measure pharmaceuticals in the marine environment. So in sediments, in marine species. So just as a comment, one aspect on which maybe scientific community should better focus on is to characterize kind of baseline of these levels of pharmaceuticals, starting to prioritize, because we are talking about more 5,000 compounds that possibly reach the environment. So we can start to prioritize to understand which typologies of compounds are present in different parts of the world. And based on that, we can also, after manage also the correlate them with demographic situation.
Yes, and also adding to what Marika and Bruno said, in a global perspective, in fact, the global population is increasing and getting old. So the profile of the consumption is changing a lot. We have a forecast of more anti-cancer drugs being consumed, and because we have older people and the chronic diseases will increase as well. So we have a more non-infectious profile of drugs, but more chronic diseases to be treated. So anti-cancer drugs will be one of the therapeutical classes that will increase more in the market, and there are reports showing this. So if we have more consumption, we have more pollution, because we still don't have the technologies for that. And what I was going to say more, I think is that. Yeah.
Kelly?
Yeah, so I was just going to add, so when you look at the global trends of pharmaceutical consumption, it is like this, and it's predicted to carry on like this. And one of the biggest factors that are given for that is our age in populations. And actually, there was a study last year that looked at, tested for pharmaceuticals in rivers around the world, and a diabetes drug, metformin, was one of the top. It was found in more than 50% of sites around the world. So things like diabetes and heart disease, it's the drugs that are used to treat those that are really, you know, these are the top drugs that are being used in huge quantities. Antidepressants increasingly used and found, and some of these drugs are not easily degraded in the environment. Like metformin is on the EU watch list because it's known to be environmentally, you know, risky. And also, as these sort of developing economies are developing, this is a new market for the pharmaceutical industry. You know, this is important that we do address this. But I would say as well, it's kind of like practicing what you preach, sort of thing. You know, it's a bit like carbon. We can't expect other countries to reduce their carbon footprint if we're not doing our you know, sorting our own sort of backyard. And I think we need to sort ourselves out, because also in terms of prevention, healthcare systems and preventative systems vary around the world. And actually some of these low-income countries have got really low use of pharmaceuticals. A lot of them use like different types of medicines as well, which we don't know very much about in terms of environmental impact. So yeah, that's just my 2 cents added to that.
Great, thanks a million. Rosa, thank you so much for coming up and asking the question. Okay, we've just a few minutes left, and so I'd like to just go along our panel. One thing I said we'd return to was research priorities. I think, Marika, you've already kind of started on this in terms of your points around, you know, identifying the baselines and priorities and so on. So, you know, maybe you can pick up on that or something else. But I want to ask each of you, so let's just make a sort of simple way of phrasing the question. If, you know, we have an EU mission, Horizon Europe mission, restore ocean waters by 2030, and we also have our UN Sustainable Development Goals and programs and the UN Decade of the Ocean and all of those frameworks, they're there. What, in your view, should be, in terms of this issue that we're addressing today, should be a critical priority for research and for research investment in the next 5 to 10 years to address this problem? So one for each, thank you.
Okay, so now I will be very concrete.
in the measures that we are taking in the world to reduce antibiotic resistance, sometimes you're tempted to say, oh, well, you know, you have to make that people prescribe less. And it's a mistake. First, you have to know the state of the art. So, you know, you have to know how much the people prescribe, how many antibiotics are prescribed, are used, and then start an intervention, and then know if your intervention works or not. And I think that here we still don't know the state of the art. I have the impression. So we need the detection of the molecules and the detection of the antibiotic resistant, or let's say antibiotic resistant bacteria, because the maps that I've shown have a high rate of uncertainty, a high rate. So we don't know still where the antibiotics in the environment and where these antibiotic resistance in the world. So for me, this mapping would be crucial, because you would be probably surprised and you would think that a region is important and then suddenly it's in another place or another place. So for me, that short-term picture is crucial.
Perfect. Thank you, Bruno.
Thank you.
Marika.
I think that maybe we should focus more a multiple stressor perspective, because from pharmacy results, for example, we observed that pharmaceuticals behavior changing considering or in presence of additional stressors like a decrease of seawater pH or changing temperature, which modulate also the degradation of pharmaceuticals in the environment. So I think that in the future, just to have a complete overview, we should investigate more this issue under a multiple stressor perspective.
Okay, so the first two are, so I'm coming to you now, Kelly, really about, before we can even solve the problem, we need to understand the problem. We need to understand the scale of the issue and the cumulative and combined impacts and so on of these stressors in the environment. Kelly, please.
Okay, I mean, obviously I'm going to say we need to work more holistically, but in terms of, you know, when we work with all these stakeholders and particularly policymakers, everyone says, we need more data, we need more data, we need to understand, we need to monitor. And we do, but so there's two things here. One is, okay, well, what are you going to do with that data? Let's say we've got that data now. How are you going to use that to make change? And you need to start thinking about that now, because with carbon, all the decision makers are only now starting, you know, the data's there and now they're starting to realize, oh, it's quite difficult actually to make these changes. So, you know, what are the wider social implications and how are we going to integrate this into our normal systems? And the second thing is, you're not going to have that data anytime soon. A really comprehensive view of what all the impacts are is not going to happen. We need action before that. So the big question is, how can we start making action before we've got all the data we need? And that was what I would be saying.
Thank you. Nenad?
Okay, this is working because it's red lamp. I think we reached a common consensus, because I would just extend what other colleagues said. I think what we actually miss is scientific evidence-based, like EU-wide impact assessment of different chemicals, and to detect the species indicators, and also to focus on specific pharmaceuticals that should be monitored. So to be able to also focus the design of the hardware and software that needs to be designed. So, and if you do like these EU-wide impact assessment, we need a European cloud that should collect all the data with cluster models and everything that goes with it, to be able to provide wide knowledge. So not to be isolated, but accessible, but by everyone that do science or that does industry and that needs to create some kind of intellectual property by using these collected and accumulated data.
Thank you, Nina. Final word to you, Tanya. Maybe.
Now it's working. I will make a link with what Marika said about the multiple stressors acting together. And I think we should also try to join the efforts with other areas, other expertise, inviting statistics, inviting other people that work with modeling, because we miss this kind of tools, these equations to apply realistic scenarios, because it doesn't work for us like ecotoxicologists making different combinations in the lab, but in fact in the real environment we will have another kind of scenario. And talking about the multiple stressors as well, pharmaceuticals, they are chemical molecules that will have different fates and behavior according to the environment. So I worked with sediments, so I will take a bit of this topic here. Because sediment, it's a compartment which is not that much the focus of the studies, and it's very effective in terms of bioaccumulation and deposition settling in the aquatic environment, especially in the marine environment. So we really should focus in the sediments, because the benthic species are eating, they are having dermal contact with all the combinations of drugs and different kinds of physicochemical processes happening there that we don't have a clue. And another thing that I would suggest is that let's make the pharmaceutical pollution topic more open to the general public, because everyone nowadays knows a lot about the microplastic pollution. But when I go to the schools to talk with the children, they say, but we have pharmaceuticals in the water. This is good for the fish, no? Why it's not good for the fish? So we have to explore this with everyone, not only the excretion, because if we have to use a medicine, we will use it, with no question about it, but how to properly dispose it in our homes, to have programs, public programs, to take back the medicines that are expired and not used anymore. So I think we should take these key messages from now and really work together, not just forget it, and let's enjoy the opportunity here.
Perfect. Thank you, Tina. Okay, on that note, it's time to draw the session to a close. First thing I'd like to do is to thank our excellent panel for a really thought-provoking and interesting discussion. So thank you so much to all our panel members. And to those actually, of course, as well. So it's time for coffee break, folks. Just a couple of housekeeping announcements before we break. First of all, for those of you who will be in the room here during coffee break, on screen you will see images of art that was submitted as part of the European Marine Board Embracing the Ocean initiative. So please take some time, or when you come back, just to take a look before the next session at some of the art the fabulous art pieces that were provided as part of that initiative. Secondly, the coffee break is thanks to the generous support of the European Commission. So our Commission colleagues in the room, thank you for this sponsoring this coffee break. And then the exhibition outside is sponsored by the Marine Research Centre of the University of Vigo and Campus du Mar. So thank you to those also for sponsoring the exhibition. We will reconvene at exactly half an hour at 4:30. So panelists for the next session, please be here a little earlier. That session will look at coastal resilience and blue carbon in Europe. But now you're released for coffee break. Thank you very much.